Welcome to solverfy.
In order to appropriately answer this question, it might be helpful to draw an energy level diagram which shows the greatest amount of energy going from the highest energy orbital down to the lowest energy orbital. So any transition that occurs to a final state of n equal 1 will likely result in the greatest amount of energy. How does that then correspond to wavelength? Well, E is equal to Planck's constant divided by the speed of light, multiplied by the speed of light divided by wavelength. So the smallest wavelength will give us the greatest amount of energy. So if we were to transition from a higher energy state all the way down to the lowest energy state, n equals 1, this would result in the greatest change in energy being represented by the distance. Greatest change in energy then would correspond to the shortest wavelength. If we were to transition to n equals 3, this would correspond to the smallest energy change, which would correspond to the longest wavelength. So of the list, the 1212.7 angstrom is the smallest wavelength corresponding to the transition to n equals 1, and 10,938 angstrom corresponds to the longest wavelength, the smallest amount of energy, going to a final state of n equals 3. And then the other three are the moderate ones, somewhere in between the two extremes, where the transition is occurring to n equals 2.